It is also a child interface. In this way, I can write child interface of collection. So list is an interface of or sub interface of collection. Set is also another sub interface of collection. Then in which scenario we will use the concept of set as collection? Just the reverse of the list feature. In list, we saw duplicates are allowed, insertion order is preserved. But in set, duplicates are not allowed and insertion order is not preserved. That point, if I will write, when we want to represent a group of data items, when we want to represent a group of data items where duplicates are not allowed, and insertion order is not preserved, then we use set as collection. This point to remember. So if duplicate I will take, so what will happen? So that we will know. So duplicates are not allowed. If I will take a duplicate data item, so we will not get any error. We will not get any compile time or runtime error. Simply that add method returning a boolean value that is false. We will discuss. Okay, the first implementation class of set interface is HashSet. First implementation class of set interface is HashSet. The same way, in which way that we saw some points of array list, in same way that we will cover some points of HashSet. It is the implementation class of set interface. Okay, underlying data structure is hash table. Underlying data structure, that means when a hash set object, I will declare internally a hash table will create. So hash table is also a built-in class name, but nowadays that is legacy. So in this way, hash table is creating containing so data items will assign. But in which ways that data items are inserting? So in data items are inserting or assigning based on hash code of the object. Hash code. Every data item, so internally control is generating a code. Suppose your name is uniquely identifying by your registration number, because your registration number is the key attribute. So if I will know your registration number, then I can happily access a particular name. Okay, so that's why data items are inserting by hash code. So searching a particular data item, that operation will be efficient. Okay, so overall you remember, so underlying data structure is a hash table. That means when hash set object we are creating, so we are declaring internally So a hash table is creating. Hash table is also a data structure. Duplicates are not allowed. Duplicates are not allowed. But if we will insert, duplicate data items, then we will not get error. Then we will not get compile time or run time error. So what we'll get, simply the odd method return a boolean value that is false. Simply add method will return a boolean value that is false. Same point, insertion order is not preserved. Insertion order is not preserved. But whatever I was telling, the data items are inserted. Data items will insert. The data items will insert based on hash code of objects. Hence, searching operation will be efficient. Searching operation will be efficient. Okay, so null insertion is also possible. Null insertion is possible. Heterogeneous data items are allowed. Implements serializable, clonable interface, but not implements random access interface. Not implements a random access interface. So basically these are the points. Okay, so some points of HashSet. So I hope simultaneously everybody is writing and everybody understanding. Then same way, so we will go to constructor, then we will go to a demo program. So constructor, we will see. So first, so HashSet, this is my constructor. So constructor, when it will execute, when I will create an object, let HashSet is equals to new HashSet. Okay, so when we declare an object of HashSet, so internally a hash table will create, you remember, and here table capacity is 16. Table capacity is 16. Initial capacity is 16. This 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 in this way. So each data item. So here you can assign the data item. Okay, but here one point, default initial capacity default initial capacity is 16, and there is a terminology fill ratio and load factor, or fill ratio, or that is also called as load factor, that is 75%, 75% or 0.75. So what is the meaning of fill ratio or load factor? That means 75% of 16. So when we declare a HashSet object, a hash table is creating having capability to contain 16 data items. But when 75% data items we will assign, then after we want to insert a new data item, then a new hash table will create. But here there is no information. So what is the new capacity? Till now that point have not included in officially. So you remember, so if load factor is 75% means, so whatever the hash table is creating, when we declare a hash set object, after 75% filling, so 75% data item when we will assign, after that if I want to insert a new data item, a new hash table will create. Then 25% is blank, so it is a disadvantage. So developer thought it is disadvantage. So same way, another way that we can declare an object, that is first set h equals to new first set, then within bracket I can write int initial capacity, int initial capacity, int initial capacity. So as per suppose my requirement is I want to assign 100 data items, so I will take 100 data items. Okay, so we can change our fill ratio percentage, or we can change load factor percentage. We can customize. So then which type of object declaration we will take? HashSet h equals to new HashSet int initial capacity, then float load factor. In this way that we can write, or last one is, so last one is common always, HashSet h equals to new HashSet within bracket, so I can write collection C. For every collection object, we can create an equivalent HashSet. For every collection object, we can create an equivalent HashSet. So in my next class, I will definitely one interview question I will present. Okay, how to avoid duplicates from array list. So if array list duplicate data item, that means all data items of array list, if I will assign in a HashSet object, so duplicates will be allowed. So at that moment, so I will explain this point. So these are the constructors, or these are the object declarations. Okay, so we can represent. So now directly I will go to an example, a demo program. Import java.util.star package, class name first set example, public, static void main, string args. So definitely I will take an HashSet object, HashSet h equals to new HashSet. Same ready-made method, let h dot add, suppose I will write John. Okay, h dot add, I will add Smith. H dot add, suppose I will write 25. H dot add, let I will insert null. Okay, then H dot add, let I will write Sachin. Then one duplicate data item, suppose I will take, but what the duplicate data item is returning, if I want to see in my output statement, so that's why I can write within output statement system.out.println. Why I am writing output statement? Because that output that we can see. So if I will take duplicate data item, if s.add method, okay, suppose I will take John. Okay, then let system.out.println this h. Now I will save HashSet Example.java. Now I will do all files, then I will save. I will go to command prompt, java c HashSet Example.java, then java space class name HashSet Example. You see, first is false and then this null. So you see, first false, this is false. Duplicates data items if I am inserting, so we are not getting any error. Simply the add method is returning a boolean value that is false. Then another output statement. So this output statement is C. So first I had inserted John, but I got null. That means insertion order is not preserved. We have written in HashSet, insertion order is not preserved. That means in which order we insert data, in any order we can get data. In which order we insert data, in any order we can get data. Okay, so insertion order is not preserved and duplicates are not allowed. So this is HashSet, but there is another implementation class, LinkedHashSet. So LinkedHashSet and HashSet difference is only in case of HashSet, duplicates are not allowed, insertion order is not preserved, but in case of LinkedHashSet, if instead of HashSet object, I will take LinkedHashSet object. LinkedHashSet is another implementation class of set interface, but here insertion order is preserved. Here I will save, here insertion order is preserved. Only this is the difference, HashSet and LinkedHashSet. LinkedHashSet is another implementation class of set interface. Underlying data structure is hybrid, means linked list plus hash table. LinkedHashSet. When I will declare a LinkedHashSet object, so underlying data structure linked list plus hash table. So only difference is here insertion order is preserved. You see now java c space HashSet example.java, then java space HashSet example. You see now John Smith 25 null Sachin. So here insertion order is preserved. So instead of or in place of HashSet, if I will take a LinkedHashSet object, so whatever the data items that we are getting, so the data items are in what? In order, in insertion order is preserved. In which order we inserted, in same order we got data. So this is all about HashSet and LinkedHashSet. Then we will go to next question, how to avoid duplicate data items from array list. So that we will discuss in my next class. So today I hope everybody got clarity array list and from list interface, HashSet and LinkedHashSet from set interface. I hope everybody got clarity. This is all about the concept of array list, HashSet and linked HashSet.